So what I would like to talk about is Airstream Live. It's a new solution developed by us in Verto, and it is a solution for content delivery over satellite, over broadcast satellite. And I will talk about the technology behind essentially the new standard stack called DVB native IP that is facilitating the solution, that is the cornerstone of the solution, and is also a cornerstone for a migration in the satellite broadcast industry from the traditional MPEG transport stream into a new IP stream, IP transport for satellite content delivery. So for those not familiar with the company, we are more than 30 years old company, serving satellite TV service providers across the world, all the Skies, Canal Plus, MultiChoice, Claro, and all the Tier 1 satellite TV service providers you may heard of, with a global reach, serving them with equipment for broadcast reception, essentially the equipment they need in order to deliver the service to the homes, to the subscribers' homes, and also providing video streaming solutions. We have a strong R&D team that is covering a diverse range of technologies, from hardware design, RF design, microwave design, software of different domains, if it's cloud, server, firmware for embedded products, mobile applications, and basically covering the entire reception chain from the roof to the home of the subscriber, with all the technologies involved. We operate from several locations, and you see this here. The headquarters is in Luxembourg. We are Luxembourg-based, with engineering and technical offices in several places, in Poland, in the UK, in Israel. The main office is in Luxembourg. We produce our products in China mostly, and have sales offices near our major markets, near our major customers. It's India, Latin America, the UK, and from Luxembourg cover the rest of the world. You can see at the bottom of the slide some of our customers. You probably recognize the brands and the logos. These are Tier 1 satellite TV service providers, but also retailers and leading distributors of satellite equipment in their markets. A quick glance on our product portfolio. Some of the product lines are really industry reference and very well known, like the LNBs, dishes, multi-switches that we are supplying to all the satellite TV service providers. We have a product line for fiber distribution, so as more and more homes are getting fiber to the home or fiber to the building, we provide the equipment that is needed in order to get the satellite TV signal and the DTT and the terrestrial TV signal into the home over fiber, because many new homes do not have coax anymore. They get fiber, or to the building. So we have the entire range of products to do that. We have Wi-Fi mesh systems, started with Wi-Fi 5 and now Wi-Fi 6. And this is to cover distribution of video streams inside the home, but it could be also a small public venue or whatever the application is. We have a line for hospitality, so hospitality head-end solution. If we need to, the customer is a hotel, for example, need to distribute satellite TV to the rooms. It's a mini head-end that allows you to combine and mix and match different programs, create your own bouquet for the hotel and distribute to the rooms, whether decrypted or encrypted up to the room. We recently entered the field of flat panel antennas, anticipating the upcoming LEO constellations that will boost internet connectivity over satellite, and the normal dishes are not relevant in that case, and it's a new breed of antennas with beamforming, phased array, flat panel antennas, so that's another product line. And the last one is what I will go into further detail, is the Airstream Live, which is a content delivery solution over satellite or terrestrial networks. So diving into that domain of the shift that is happening with the introduction of DVB NIP, DVB Native IP. It's a new standard, actually it's a stack of standards that includes under that DVB MABR, DVB-I, DVB-HB. It's a set of new standards permitting the distribution of IP-based content over satellite. So far, for those who know, the satellite transport was always based on MPEG transport stream. If you needed to transfer IP, you could, but it was like encapsulating that IP traffic into MPEG transport stream, and this is what the satellite industry is now getting rid of and migrating into native IP, so there is no MPEG transport stream in the middle. And all the streams that you have from OTT services like Dash, HLS, or any type of file basically can be broadcast over the satellite in IP form, which makes it very easy on the receive side. There is no need for transcoding, and you can play back on smart devices the original content in its original format. The main driver for that is what drove OTT basically, is the consumers' behavior and wishes to get TV everywhere, anytime, and on any screen, and in high quality. And there was a huge effort of the industry to deliver that. So with OTT it's possible, but OTT is only working in locations where you have good broadband internet connectivity. However, there are lots of places, and delivery over satellite is the only way. Whether it's a boat in the middle of the ocean, whether it's a rural community in Africa or somewhere else in Latin America, it doesn't matter. Whether these are rural schools, or on the plane, or many times on a train, whenever there is no broadband connectivity, satellite is the only way. And native IP and the technology behind it, which is multicast ABR, is actually what made the big change and made it possible to deliver OTT content to those rural places, unconnected places. The satellite offers unique benefits, and this everyone knows. The satellite is the best platform to transmit from one to many. So, and the benefits are reflected in several parameters that influence the quality of the service and the quality of the experience for the end user. So, for example, lower latency, satellite transmission gets directly to the edge where the end consumer is. and doesn't need to go through all the servers across the internet network, the public internet network, that always just accumulates more and more latency. Satellite is, once you broadcast, it's in less than a second, in a few hundred milliseconds, it's already at the destination. High quality video, the internet, because of its unmanaged nature, has difficulty to deliver all across high quality transmission like HD or 4K, and satellite provides you this fixed quality of service, and therefore you can always get the high quality profile of the video. Uninterrupted streaming relates to the same, that internet is not such a stable platform, the public internet, and therefore there are sometimes congestions and things that interrupt the streaming, while this is not the case for satellite. Network costs. The satellite network costs are fixed. There are no surprises at the end of the month. The service operator has a contract with the satellite operator, and he knows exactly what the bill will be at the end of the month. While OTT services that are based on CDN, the monthly bill is not so much controlled. It could be surprising sometimes, and we hear it from customers that the CDN bill was rocketing, because it depends on the consumption, on the traffic that was used, and therefore it's difficult to control. If you want to extend the service, satellite is again the best, because from a single location you can cover like 1/4 or 1/3 of the world. So it's very easy to scale the service and get to new territories. While with the OTT is slightly more difficult. You have to extend your CDN network and install servers and make an effort to get to bring the edge of the CDN closer to your customers, to the end user. And the resilience is another advantage of satellite. We have seen what happened in the recent dispute between Russia and Ukraine. The first things that is being broken are the terrestrial infrastructure. So, thanks to Elon Musk, who gave them some tens of thousands of his own terminals, and based on satellite they could maintain communication. So satellite is much more resilient than any terrestrial infrastructure. That's another advantage. And the last one is the ability to offload congested networks, whether it's a mobile network or a terrestrial network, with many consumers streaming at the same time. If there is a prime event, for example, the network is likely to face congestion, and the quality of experience will be dramatically impacted. And again, this is something that is avoided when you use satellite. So I hope all these benefits convinced you that satellite has a lot of advantages, and therefore worth using when it comes to delivery of content to any audience, whether it's an OTT subscribers, whether it's rural schooling somewhere, or whatever the case is. And the cases, as I mentioned, could be from direct to home, direct to vehicle, or direct to edge. I have a slide later on the case of direct to edge, where satellite is actually assisting CDN edges or 5G nodes and beaming content directly to the edge of the network, so end users that are streaming from the nodes will get the content much quicker. So this slide basically depicts the overall flow of the distribution of content over the satellite, and in particular gives a snapshot of our own solution and a unique angle of it. Basically, we made the service cloud-based, and we offer it as either as a cloud service, but also as an on-premise installation if it's needed. And we basically, customers that are using the service gets a login credential, they log on, and they can upload content of any type through the cloud, over the cloud service. And of course, there are all the APIs needed in order to automate the process and access media servers directly. So if you have a media server with an OTT set of channels, streams, or if you have a media server that is a server of educational material, it doesn't matter. We can connect to any of these content servers and ingest the content, pull the content, or let the servers push the content into our service. In our service, you can do some content management, and then we prepare it for transportation or transmission over satellite, and then we basically transmit it to the teleport. The teleport will have a modulator, and the latest generation are GSC DVB-S2X modulators that are very efficient for the IP delivery. And then it's uplinked over the satellite. It's received on the rural edge or wherever you want to receive it. And there, over Wi-Fi, you can distribute the content to your smart devices of the subscribers, of the customers. So it could be a smartphone, a tablet, or also a big screen connected directly over HDMI cable, for example. So we split the two parts of the flow. To the left side, we call it near edge, the edge, and that's basically the flow. So just to summarize, on the server side, it's either a cloud service or an on-premise. The technologies are web technologies with containers, Dockers, very modern. On the receiver side, it's basically a low-cost receiver, and then an edge caching to cache all the content. It's not a must, it's optional, because you can stream directly from the receiver as well. But for some use cases, you want to have a local caching edge on the far side, so that's also optional. And then the satellite can be either unidirectional for broadcasting, or can have a return path that can be useful in many cases. For example, if you encrypt your video services with DRM, and you need to access the license of the DRM in order to decrypt the content. So you may need a return channel. Another thing is for analytics. You want to transmit back all the information of from the application that your user is using, and create a profiling for the households or for the user, so you can use it for targeted advertising and this kind of applications. It's not a must, but it's very useful to have a return channel. In this slide, I take one use case, which is the CDN edge, transmitting content to CDN edges and 5G nodes. It's in fact a model that we implement within a project of ESA, the European Space Agency, called 5G Emerge, and where there is a consortium of more than 20 companies working together, collaborating together to implement that solution. And we are a key player in that project. And this project involves a sophisticated caching system provided by Varnish, who is actually also in this show. And our two systems work together in tandem, where they generate the profiling of the end user, and basically instructing the caching management system on the near edge on what content to fetch and transmit over the satellite. So next time a user will want it, it will be already there in the, next to it. And this is used for both CDN edges or 5G nodes. So the possibility to transmit content directly to the 5G towers and store it there helps bypass all the network of the operator, basically of the mobile network operator, and offload his network and making the content available off the tower for a much better quality of experience for the users. And for the CDN, the same benefits. You just predict what content is going to be used, and you make sure you broadcast it over satellite to the edges of the CDN, so it's ready there for the time it will be consumed. Here is a short video clip showing just our cloud service, just to give you a feel of the service. So as I mentioned before, you get a credential, you log in, and you can upload your content. You choose whatever files you want or live stream, as you can see the last line. You hit broadcast. Once you did that, the content is packed in MABR and transmitted to the teleport for uplink. And on the receive side, it's received and being available for consumption over Wi-Fi, local Wi-Fi, over smartphones or tablets or any other smart device, or a connected TV over HDMI. It's also possible. So this was about the system, its architecture in a very high level, and just wanting to repeat again the use cases that it supports. So e-learning applications for rural schools, as I mentioned, and we have cases like this. We have a prospect in Africa that bought a huge library of education material and is basically aiming to distribute them over satellite to rural schools. But rural schools, rural libraries, these are activities that are supported by local governments as well, and the satellite is best to do that. Obviously, there is the TV services, which is OTT today, so OTT over satellite. And as I mentioned in the beginning, the fundamental shift from MPEG transport stream to IP stream over satellite. And so the DVB NIP project did not forget that there is always an interim phase where people have some legacy operations and cannot switch from one day to another from MPEG transport stream to IP-based delivery. And they marked a migration path through an MPE. It's a part of DVB, the old style DVB, but allows you to do IP over the MPEG transport stream. So even if you have old set-top boxes, you don't need to upgrade them. You can just need to update the firmware there. And if the set-top box is having the right processing power, you can use it for the new DVB NIP delivery, and you don't need to replace it. Obviously, an operator that wants to start a new DTH service will start directly with the DVB NIP based on GSC, because this gives it the most efficient delivery of a satellite. Yeah, delivery of files to public sites. This digital signage, we may be combining these two, and even also the smart cities and video services. So places where, again, there is no good internet connectivity, and you want to deliver content on huge screens, maybe covering a building or whatever, and the files are really large because of the resolution and so on. And if you don't have the right broadband connectivity, then satellite is the right way to access and deliver the content. E-health, telemedicine, video applications, that's again for rural communities that have their clinics or hospitals in mobile trucks or whatever. Even in the COVID time, there were some COVID test trucks that were going from one place to another. So similar way, there are these kind of mobile clinics, and they also need medical information, files, videos, whatever, and satellite is a good mean to transfer them. Download to carry and Wi-Fi hotspots, it's a use case we have seen in several places in Africa, also in India, where consumers in shopping malls, for example, they have a station somewhere, they can come nearby with local Wi-Fi, they can download content, movies or series or whatever, and it's bundled normally with other services, like if it's a supermarket, if the shopper gets into the supermarket, if he buys at a certain amount, he gets a code. With this code, he can download a free movie. And since these locations are not well connected, delivering the content to these locations is only by satellite. Delivery of any media, live TV, live streaming to vehicle, sea and air, whether it's for the passengers or for the crews. So that's for the crew, it's entertainment, but not only, there are also operation manuals and training videos and other type of content. So obviously when you are in the middle of the ocean, you probably don't have any return channel, and delivering over satellite broadcast is doing the job. And the last one is what I had a slide about, is the delivery of content to CDN edges and 5G nodes. And as I mentioned, part of the ESA program that is called 5G Emerge, we try to make sure that we are doing this in consistency with the protocols and standards that are defined by the 3GPP, especially for the mobile edge computing parts, which will allow our equipment on the 5G tower to interface with the 5G equipment vendor, whether it's Huawei or Ericsson or Nokia or whatever. So we try to make it compatible with the standards that the 3GPP are supporting. Basically that's all on that. I invite you to watch a live demo of what I've shown here at our stand. We are just here on the right side. You can see the inverter logo there. And we will be able to go into further details and explain every step in the flow and discuss different use cases or requirements you may have. So that's all.